I'm going to walk through this problem with you, and it's a problem I've always really liked. I think it's a very rich problem. So we're given a situation here where a random sample of students taking college calculus leads to two least squares analysis regarding college calculus grades, SAT scores for men and women. Men, you'll notice over here on the left, women on the right. Then we're told the student scores 689 on the SAT math exam, then receives a grade of 85 in the college calculus class. What would you guess is the student's gender? All right, so what we're going to do is we're going to really break this down and analyze it a little bit. We're going to start with the males down here. Now, first thing I want to do is I'm going to create a least squares regression equation. So, what I'm going to start out with is we are trying to figure out calculus score. So you notice I'm going to make that my y equals, we've got a constant right here of 50.89. Notice I'm just jumping straight to what I need. I don't need this other stuff yet. And then I've got my slope here of 0.047. I'm just going to round it up to 77 over 1 times SAT score. So I have that for the men. Or males, rather. And I'm just going to shrink this down because I'm going to use it later. I'm also going to look at a few other things up here. I notice that they give me an r squared value right here. I'm going to keep that in mind. R squared equals 0.377. Now, to figure out my r value, I just have to find the square root of that. I'm going to plug that in. Hopefully you did the same thing I did. And you get about 0.614. Which tells me that I'm looking at moderately strong, I'd even say close to weak linear, positive linear correlation here. So I'm going to bear that in mind. Now for the women, I'll do this in a different color. All right, so I'm going to go back up here to, again, we're trying to figure out calculus score. I'm just going to abbreviate this time. I've got my constant of 22.19. And I've got my slope of 0.096 times SAT score. All right. And I'm going to take a look at my r squared. I got r squared of 0.796. So I'm going to figure out my r value to tell me just how strong this correlation is. So square root of 0.796, I get 0.892. That's pretty darn strong. It's stronger than what we noticed for the males. And that's something we're going to want to remember down the road a little bit here. All right, so now they tell us a student scores 689 and receives a grade of 85 in college math class. We have to guess the student's gender. What am I going to do? I'm going to plug in these values and see what happens. Let's see. So I'm going to plug in that SAT score of 689. We'll try it for the males first. So we're going to do 0.5089 plus 0.0477 times 689. We'll see what we get when we plug this in. Hopefully you're doing the same thing I am. All right, and I got 83.75. Now, we know that they received a score of 85 here. So we'll go with what we see minus what we expect, and we'll figure out what our residual is. All right, and I get negative 1.25 for my residual. That looks pretty good at first glance. We're going to hang on to that. So we got a really small residual here. Let's take a look here when we plug it in for the female. 22.19 plus 0.096. Again, we're going to plug in that SAT score of 689. Plug in these values, see what we get. 0.096 times 689. plus 22.19. Okay. In this case, we get 88.33. That's what we would expect now. So we're going to take what we see. Let's see. We're going to take what we see. Oops, I should have done that back here. I made a mistake, and we're going to fix that. That's okay. We can fix that. Because again, residual is C minus expect. I went the other way around here, so we're going to fix that. What I saw here was it says the student scored. It tells us what they scored, 85. We expect them to score 83.75. So I was just going to change it up a little bit. I'm just going to get a residual of positive 0.125 in this case. That's all. But that's good. I'm glad we went back and reviewed that, because sometimes that can be tricky. Remember, residual is what you see minus what you expect. Here I figured out what I expected to see. This is telling me what I do see. All right, so again, I saw 85. I expected 88.33. We'll figure out what that residual would be. 85 minus 88.33, negative 3.33. So on first glance, you might be thinking, oh, this student must be male because that residual is a lot less. We got a residual of 1.25 as opposed to a residual of negative 3.33. So you might be inclined to think, oh, it must be males because that residual is a lot smaller. However, we're going back to a very important piece of information here. Look at our R values here and our R squared. Our R squared tells us that only 37.7% of data was accounted for by this least squares regression line. And it's also telling us the strength of that line is 0.614, which is, moderately strong. However, if we go to the females here, you'll notice that 79.6% of data was accounted for by that least squares regression line. When you look at the strength, 0.892, that is significantly stronger. So when you look at these residuals, okay, 1.25, and then you have one that's negative 3.33, so looking at a difference of a couple of points here, really, off of what you'd expect. But given that your R value is a lot higher here than it is over here, using that R value, that tells me that since this line is a lot stronger and it counts data a lot better, I'm going to have to say the answer is female here. So what would you guess the student's gender and justify the answer? I would guess that would be female, and the reason is because the residual really wasn't that high. We're not talking like 10 points or anything. It was only 3 points, and the fact that our R value is pretty high tells us it's a strong linear correlation, positive linear correlation. Whereas if you look over here, yeah, it has a smaller residual, but your R value is a bit less. You're looking at moderate correlation. I wouldn't even say strong. I'd say it's kind of like a moderate, bordering on weak almost. Actually weak would probably be less than 0.5, but it's not very strong. So the fact that this equation here is a lot stronger, we're going to go with female. So I wanted to walk through this because it's a really rich problem, has a lot of ways that you can interpret it and analyze it, and it's a great use of linear regression. So hopefully you did okay with the problem, and if you